All right, here we go. So again, we went through all of the properties. We went through all the properties that we learned yesterday. Let's use those properties to solve these first three problems. Now I got 3 to the negative second here, right? Is the 3 happy?
No.
Move it down. Shh, 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 shh. And when you move it, the power becomes positive. As I was walking around, I saw a lot of people move them, but then didn't turn that exponent positive. Like you left it negative still. The process of changing the orientation, top to bottom to top, is the process that makes it turn positive. X to the negative, is X happy?
No.
Move it down.
X5.
X to the fifth, please. What happens with Y to the 0? Becomes a 1. Now, do I need to write times 1? No. I'm okay if it just like goes away. Everything shifted down to the bottom. What do I put on top?
1.
Yeah. All right, so now this becomes, and now I'm not done yet because there's still a number that needs to be evaluated. What is 3 squared? 9.
Oh,
Yes, please. And I don't know if I was clear enough on that yesterday. I don't know if I had said that enough because, again, as I was looking at homeworks, I saw a lot of people leaving those numbers raised to powers. Turn the number into a value. Yeah.
So if it's just a number and an exponent, you just make it simplified?
Yeah.
Okay.
Is it wrong to put like 9 times x or like say?
That's fine. If you put a little dot there, that's no big deal. Yeah.
What happens if there's all the numbers on the top and none on the bottom?
You could write over 1, but you don't need to.
So you could just put those numbers in?
Yep.
That's it?
Yep.
All right.
All right, let's take a look at number 2. Is 8 happy?
No.
No, move it to the bottom. What happens to P?
Cancels out 1.
Cancels out. It goes to 1, right? What happens to Q?
Goes out.
It's negative. Make it happy. Put it to the top. Is R happy on the bottom?
Yes.
Yep. Yeah. Okay, last thing. Just make that 8 squared 64. So Q to the third over 64 R to the fifth. Again, whenever you have a number raised to a power, finish it out. Evaluate the number raised to the power. Last one here. Again, this is one that we talked about earlier. Power to a power means we multiply.
Why don't you move the R?
Why don't you do the 9?
That's a P.
That's a Q. Yeah, it's a Q.
Why don't you move
It
the
looks
R?
like a 9.
If it's
I know it's my Q's and my 9s look similar. That's why I write the line in there. We good there?
Yeah.
Yeah, but I think that's a good thing to talk about. Why doesn't the R get moved? Because it's positive. It's happy where it is. Don't move it. All right, let's look at number 3. What should the power on Z turn into? Negative 12, right? Power to a power means we multiply, so that is Z to the negative 12th power. I like to put a line in my Z's too so that it doesn't look like a 2. And thank you. Yeah, now we have to do a 1 over Z to the 12th. What am I talking about? You guys are good. Man, you guys are like good with this. I don't need another day. Yeah. I didn't hear that. I didn't hear
I think we need the other day.
I need to put it
All right. Shh. You know what's crazy? You know what Mr. Delap and I did?
What's that?
We planned out every single day until the state test. What we're doing every single day.
You got like FaceTime or something?
We have 8 days unplanned, and it takes like 6 days to do the statistics chapter. Okay? It's only just like no. We are nose to the grindstone before our test. Oh yeah. You ever heard that phrase, nose to the
So
grindstone?
then movie and then the 5 days.
That's snacks and college.
No, that's just until the test. The test comes mid-April. Yeah. So I will say this: every day is accounted for. So if we push back a day, that's one less day that we have to review. One less day that we can review before the test. So it's like, okay, if we really want to push back a day, it's got to be a We have to. Yeah.
So, are we gonna watch a movie
What's this, an English class or something?
after the test or something?
We don't watch movies in here.
But like
We got work to do,
You watch one in
Gio.
social studies?
We got work to do.
watching
Wait, yeah, what is this, a social studies class?
hypothetically.
We're not a social studies, we actually do work in
If
here?
we're
Okay.
done with the test, though, like,
Oh,
we watch a
watch
movie.
Hypothetically, no, metaphorically, yes.
We're not watching Lion King in here. Come on, man.
We watch the Spider-Man movie.
Right.
We can
We
watch
can't
like
do that. We got math to do.
Wait,
We got work to
we
do.
can watch Moneyball. That
Elaborate. That's elaborate. Extra 6 times, like what you said about how where you work here.
and it involves numbers.
All right, let's take a look here. Shh, no. What are you gonna ask?
Well,
Here we go. This is gonna get off topic again.
maybe.
We got stuff to do today.
Yeah. I got a plan to start the video.
Yeah, this is all I'm doing.
What's up, boy?
Do you like miss the laugh, just like chill and like?
Yeah, we hang out on the weekends. You know, just like
Do you guys snuggle?
Go bowling.
What?
Or like go like on coffee
They
dates
get a
and talk
beer.
about school.
yeah, all the time.
Go to the firehouse.
You guys have two balls?
Yeah,
You guys have picnics and.
yeah.
Let's
In the
go
park.
with random question about everything.
Do you eat lunch meat?
Actually, we do eat lunch. We do eat lunch together.
Yeah, you
All right.
can just do that for me.
Okay. Let me first start off. Are there any questions 1 through 7?
No.
Just 1 through 7. Yeah.
You're gonna go over number 7.
Yeah. Because this one we have to reduce a little bit, and that you might not have caught that. Let's take a look here. Is the -3 happy? Move it.
No.
Is the 6 happy?
Yes.
Move it. No, it's not happy. Negative exponent. That's what I'm looking at. This tells me that it's not happy. Now, the 6 squared on top becomes 36. The negative has to stay 27. You have to recognize that these are both divisible by 9. Reduce the fraction. Okay,
Good work.
make sense?
Yeah, thank you.
I did not.
The part that I just missed was the whole number on 3 doesn't change too. That's what I missed.
Right. Yeah. Watch out for that. Shh. Watch out for that. The negative out in front of the 3 does not change. The only thing that changes is the negative is up in the exponent. Said.
We should just jump into the next.
Well, I need to finish going over the homework. What other questions do we have? 9 to 17. Yeah. Number 17. Shh. Stop talking. Okay. Is 2 happy?
Yes.
Yeah.
6 and 8.
Is Y happy?
Nope.
No. Is 8 happy?
No.
What happens with Z?
It turns into 1.
Turns into 1. It goes away, right? Is X happy?
No.
Okay, so now on top, I've got 2 squared, which is 4, times 8. 32. Leave the X to the 7th, leave the Y to the 6th. That make sense?
That's not what I got, but
What's wrong, Tommy?
Would you use
Stressed
8?
out.
The 8 combined with the 2 squared. Like 2 squared is 4. And what's 4 times 8? 32. It's just a number. You just multiply it. Yeah.
Wouldn't it be because the 8 has that one exponent? Wouldn't that be 8 times 8?
No, that would be like 8 squared. You're thinking of 8 squared. 8 times 8 is 2 of them there. So it's really just like 8. Just once. Make sense?
Yeah.
Okay, any other questions through the end? 25?
I'll do that on homework tonight.
Okay, let's get into the notes for today then. Again, we're going to get through as much as we possibly can. Whatever we don't, we'll just pick up tomorrow. I think we'll be fine though. At least you get through all of the properties. Realizing it's more Tommy than Noah. That was all the comments.
It's mostly Noah. I'm very chatty.
I don't know about that.
That was a real fun just elaborate. Good one. Only suffers.
I did it again with the dad jokes.
He said, I don't know. It's gonna be like no one knows. You really use a car. So no.
Remind me to laugh later.
I'm off at 6:45.
Oh, then no.
No, 6:21.
I know.
All right.
No, Josh.
Shh. Okay, here we go. So this is just the rest of the properties. I first want to start off by talking about this first one here, the product property. Now look at what I have. Look at what the scenario is. And again, this is not on your page. I'm just going to show you by demonstrating this one. Everybody look up here. Something raised to the third power is that thing multiplied over on itself 3 times, right? Those parentheses aren't really doing anything though, because it's all just multiplication, right? So I'm going to take away those parentheses and change that into just multiplication signs. Well, that means the only operation is multiplication. So I'm going to reorder, because I can do that because of the commutative property, right? So now I can say, well, this is just 8 to the third times x to the third. What's the rule to go straight to my answer? What's the rule to go straight to my answer?
You put the exponent on each value.
Yeah, you're basically distributing the exponent. Okay? That's the rule. You basically distribute the exponent. If you've got 2 terms inside parentheses, go ahead, write that in. That is on your papers now. If you've got an exponent on a parenthesis, and there's multiple things going on inside that parenthesis, you just distribute that power to each piece. So this would be a to the n times b to the n. Just give that nth power to each piece inside that parenthesis. So for example here, this is like saying 2 to the 4th times h to the 4th. And then we could just finish that out by saying, well, 2 to the 4th is 16. 16h to the 4th. And then that would be done. Okay, so if you've got 2 things inside a parenthesis, you're just basically going to distribute that power to each thing inside the parenthesis, each term inside the parenthesis. Okay? Now, I want you to look at both examples A and B together. Look at examples A and B together, because there's only a slight difference between the two. One has parentheses and one does not.
Is a negative 2 and y?
Okay, let's take a look. Is the negative being squared? No. So the negative must stay. That's not being raised to any power. Now we bring that 2 squared, y squared. Oh, why did I say 4? Whoops, sorry. 2 squared, y squared. Oh, now I know why I said 4. Because what is 2 squared? 4. My brain was ahead of myself. Now, if there is parentheses there, what is being squared now? A negative 2. Like now we can write it like this. What happens to the negative now? It's going to go away. Negative 2 squared is a positive 4. So notice the difference between the two. One of them is positive and one of them is negative. The one with the parentheses is positive. The one without the parentheses stays negative. Question?
Yeah, how come it turns to positive when the exponent that's being multiplied by is not negative as well?
Don't think it's not the exponent that's being multiplied by. It's being raised to that exponent. And if it's an even exponent, the negatives will match up and go away.
Just not gonna think about it, then?
All right, let's take a look at the last, not the last one, example C here. Now watch, I've got multiple terms inside, right? So this is basically saying x to the 6th squared, right? And then y to the negative 3rd squared. Okay. See now, again, like I said at the end of the last section yesterday, now it starts to get a little bit more difficult because we're going to combine the different properties going on. Yeah, I did this product property, but what do I have to do now? I have to multiply the exponents because I've got one of these power to a powers. So you're going to see several properties within a single problem. What's the power on y? -6, because I have to multiply. Power to a power means I multiply. See, and again, can I leave that as my answer? No, I've got to do this negative exponent property where I have to shift the y value down to the bottom. So this turns into, okay, x is happy, y is not, move it down to the bottom. And that's where the difficulty is for a lot of these problems. There's multiple steps to each problem where you have to say, okay, what's the best course of what's the best thing to do first? Remember, simplify it all the way down. Yeah, no.
Are we gonna have a quiz this week or not?
No, next week. Next week. Okay.
Like Wednesday or?
I don't know. I mean, if we're adding in a day now, then I have to change that. So. All right, so we have -5 t squared squared. You know what? Just for the sake of time, let's skip to example E. Okay. Here's what I will say. I am definitely okay if you take the power and you bring it in. Like, what's going to end up being the power on x when I distribute that in? 8. I'm totally okay if you jump to x to the 8. Okay? Why is that happening? Because it's x squared raised to the 4th power. So I am totally okay if you just say, okay, x to the 8. And then y to the 12th, because I'm taking power to a power, I multiply. And that's multiplied with x to the -8 and y to the -16. Now, okay, I did my product rule. Don't I have like bases? Okay, what happens with my x's? They end up canceling out. They end up getting x to the 0 because 8 plus -8 is 0. And what is x to the 0? 1. Yeah, so it ends up just canceling out. It ends up just being a 1.
So would 1 go on top? Or you wouldn't even count?
You wouldn't even write it,
All
right?
Just say 1.
So this ends up canceling out.
And then this would be -4.
Right, and then we have y to the 12th and y to the -16th. I add those together to get y to the -4th. Now, can I leave that?
Yes.
No, it's
Not happy.
Oh, it's not
So
happy.
you have to put a 1.
Oh,
So it's 1 over y to the 4th. Okay? See how this, it all comes together. All of these things that we learned yesterday, combining with all the properties that we're learning today, it does get a little confusing. I get it. Okay, now we've got the power of a quotient property. So if you've got a power on a division, on a fraction, it's kind of like the exact same thing as the product rule. We had 2 terms multiplied inside parentheses. When you've got 2 terms divided, it ends up being the same thing. Let me show you. Isn't 2/3 raised to the 3rd power just that as repeated multiplication? Now, no common denominators needed. I could just multiply straight across on top and on bottom. So that ends up being 2 to the 3rd over 3 to the 3rd. What do I do to go from here to here? Same thing. Basically just distribute that power to every piece. Every piece in the numerator and denominator. Okay? So if you have a over b to the nth power, it's a over n divided by b over n. It's a over n divided by b over n. So for example here, x over 5 to the 3rd power would be x to the 3rd over 5 to the 3rd. I'm basically just distributing that power to everything in the numerator and denominator, everywhere. Everybody gets a power. Okay, well, 5 to the 3rd is just 125. we have it. Questions about that one? Okay. I'm going to skip example A. So let's jump straight to example B. And I've got 3d squared over EF, all raised to the 4th power. So do you see how there's multiple things going on in both the numerator and denominator? That doesn't matter. We still just distribute the power, and it's got to go to everything. Hold on. It's got to go to everything. The 3, the d squared, the e, and the f. Now be careful here. You know what I always have people tell me? That this should be a 12.
Because they multiply 3 by.
Because you multiply 3 by 4. Be careful. You're raising 3 to the 4th power. Is 3 to the 4th 12? No, it's a lot bigger than 12. So leave it as the exponent off the bat. Now, do I multiply 2 and 4 here? Yeah. Okay, that I do multiply. I see what you're getting at because you do multiply power to a power. But you don't multiply a number to a power. And then E gets the 4th power, and F gets the 4th power. There is something to simplify. I do have to take 3 to the 4th. That just turns into 81. 81 d to the 8th, e to the 4th, f to the 4th.
You just multiply the 3 because it's actual number. You multiply it by 4. Like you do 3 times 3 times 3 times 3. And you get, that's how you get it again.
You want to know how? Look, okay, 3 to the 4th power, right? 3 times 3 times 3 times 3. What's 3 times 3?
So it's 9 times 9.
Oh,
Basically
9.
saying it's 9 times
What's 9? What's 3 times 3? 9. And then so we have 2 9s. What's 9 times 9?
Because 9 times 9.
Or just get a calculator equation, I guess, right?
9 times 9, 81.
Get out your calculator, Tommy.
All right, last one here for this set. Now, okay, a lot of different. Thank you for confirming that. I wasn't sure about myself there. There's a couple different things that we could do here. Okay. Here's what I would do first. I would go inside out. You might be tempted to bring that 2 in. I'd say hold off on that. Because do you see in the denominator? I have that 3 I could distribute. Yeah, remember that in order of operations, you got to go inside out, right? So this is 2x to the 3rd over x to the 3rd, y to the 3rd. Now everything is squared. Now I could reduce my x's now, or I'm actually going to do that in a second. I'm going to do that in a minute. Okay, we've got 2 squared. X to the what? 6th. Same thing on the bottom. X to the 6th. Y to the 6th.
You only just make it 4.
Well, watch out here.
You got that, yep.
What happens with my x's? I would subtract them, but they end up canceling, don't they? 6 minus 6 is 0. And anything raised to the 0 power will go away. 4 in the numerator, y to 6 in the denominator.
So you just have to do these really slow.
Yeah, and that's the best route to take. Take it piece by piece. Take it step by step. Because if you try to do too many steps at once, you try to look ahead, you're gonna miss what's right in front of you. Take it step by step. If you do that, then you'll be fine. It's just step by step. Just property by property. All right, flip it over onto the back. We're going to take a look at our last property, which actually isn't new. This is something that's, it's not really even its own property. It's kind of like this one. It's kind of like this negative exponent property. Let me ask you. The quotient property said to distribute it in, right? Okay, if I distribute that in, won't that make that a power a negative?
Yeah.
Doesn't that shift to the bottom?
Yeah.
So you just flip them.
If I bring that b in, wouldn't it make that negative? So wouldn't it shift to the top?
Yeah.
So in essence, all you would do is just flip the fraction and take it to the positive power. That's the rule that we have. B over A, you flip the fraction and turn it to the positive power. This is a very unique case. This is a very special case, one that does not happen very often. But when it does, it's really easy to get the negative power to go away because you just flip the fraction. Then you just treat it like any other quotient and bring that power in. Okay? So for example here, we had x over 3 to the negative fourth power. Question?
Yeah, so when you have your negative power, I mean, it basically just flips everything.
Yeah.
Okay.
So like here, what I mean here is that 3 will go on top and the x will go on bottom. I take the reciprocal of the fraction and turn the exponent positive. So this would end up being 3 to the fourth over x to the fourth. Oh, hey, look at you, 81. Superstar. Shout out, Miss
He checked that on his
Simone.
calculator.
Calculator for it. I got this
Calculator.
This
All right, one last set of examples. I'd like to jump to example B. Okay, I'd like to jump to example B. Take a look at this one first.
There's no little parentheses this time.
Now, I'm going to flip the inside of the fraction. The y to the third is going to come to the top. The 2x squared is going to go to the bottom. And the 2 on the outside, flipping the fraction, turns the exponent positive. Flipping the fraction turns the exponent positive. So now this becomes y to the sixth, 2 squared, x to the fourth. And then 2 squared is just 4. So y to the sixth over 4x to the fourth. This is exactly where I got to first period, so I'm going to stop. I'm not going to try to do that last example. I already took off the problem that looks like the word problem from the homework, so the homework should be good. Okay?
Same page.
Same page. We're good. Tomorrow we will finish the guided notes. We will do a couple of those, like we'll do example C there, we'll do example 4, and we'll kind of hit some of the stuff that we missed, and then do more of these exponent problems. Sound good? Okay.